Okay, pretty much every chapter goes like this. The physical domain of development, the cognitive domain of development, the social-emotional domain of development. In Chapter 2, you guys are going to focus on the physical domain of development, and you're mostly going to do that on your own. In the beginning, it talks about what is a gene, what is a chromosome. I'm assuming that some of y'all have had that already in biology. And if you haven't had it yet, I'm not the best person to explain it to you. Go over genes and chromosomes and what are autosomes and all of that. That's going to be in that beginning section of Chapter 2. What I'm mostly going to focus on is going to be the cognitive and the social-emotional domain of development. I am going to talk a little bit about the physical domain of development, but I'm just forewarning you that you're going to have to do more of that on your own. Does that make sense? Okay, so review genetics, biological foundations, stages of prenatal development, prenatal care, birth process. Go ahead and review those things independently. Yeah. Okay, I'm going to pick up where we're talking about genetic disorders. Genetic disorders, when we talk about genes, what are genes?
What you're born with.
What you're born with, okay? There are a set of genetic traits or genetic characteristics that you inherit from who?
Your parents.
Your biological parents, right? Okay, and when we're talking about inherited disorders, these are genetic. Some genetic disorders are inherited by a single gene, a chromosomal problem, or another genetic factor. If both parents have the gene for the disorder, then you are more likely to have that disorder. Okay, so it's going to talk about, and your book's going to review with you, dominant genes and recessive genes. Have y'all heard of that before? Okay, so both of your parents, so let's say I have a recessive gene for sickle cell anemia. Does that mean that I have sickle cell anemia? No, so I don't have it, but I'm a carrier of it. Okay, and my husband can also not have sickle cell, but also be a carrier of sickle cell. And if we have a child, that means what?
Your child could either
Our child could have it, okay? It doesn't have to, but my child could have it or be a carrier of it, right? So that's recessive inheritance, where both parents carry this gene recessively, and even though we're not expressing that disorder, we could be carriers of that disorder and pass it on to our children. Does that make sense? When we talk about sex-linked chromosomal disorders, these can be carried on the X chromosome. And men are more likely to develop X-linked chromosomal disorders, X or sex-linked chromosomal disorders, because in females we have 2 X chromosomes. So if one of them is defective, what happens? We have 2 X chromosomes, and one of them is we have 2 boxes of candy, and one of them is spoiled. What can we do with what can we do?
Eat the other one.
Eat the other one, right? So if you have 2 of them, and if you have 2 of something and one is defective, you can rely on the other one. Does that make sense? Right? So, however, in men, if you have an X and a Y chromosome, and your X chromosome is defective, what happens?
That's it.
You have a disorder. Okay? So that's why males are more likely to have sex-linked chromosomal disorders, and more likely to express those disorders. For females, we can be carriers of sex-linked chromosomal disorders, because just because I have 2 X chromosomes, one of them may be defective, even though I'm not expressing a disorder. So they're common in males, because males only have 1 X. If you flip to page 60, if you have your book, there are some in there. Sex-linked disorders. Hemophilia is one, the inability to have blood to clot your blood. Fragile X, cognitive deficiencies. The one that I'm most familiar with is hemophilia. And there are a few other ones. And essentially, what happens is they're more common in males because there's only one X chromosome. So make sure you know for inherited disorders that these things are coming from your genes from your biological parents. Okay? Chromosomal disorders. These disorders stem from missing, duplicate, or damaged chromosomes. This often originates during fertilization. So at some point during fertilization, when the zygote is formed, there's some sort, either a duplicate or a missing or a malfunctioning chromosome, and that could then turn into some sort of chromosomal disorder. The probabilities increase with a mother's age. So a lot of times, there's examples on page 60 and 61. So a lot of times, there are risk factors for these things happening, and a lot of times they'll say like the like the best years, like the best childbearing years are, I've heard 25 to 35. I've heard typically after the age of 35, the probability of having more chromosomal disorders increases. But I know some of that research changes frequently. So again, probabilities increase with a mother's age. This is something that where there's a defective chromosome as the child is being developed. So yeah, for example, a 25-year-old woman has a 1 in 476 chance of having a baby with a chromosomal disorder. Once you reach 35, it's 1 in 192, and once you're 45, it's 1 out of 21. So again, the probability of this increases as a woman becomes older. The two most discussed are, the one that's most common is Down syndrome, which is trisomy 21, and there are a few others that are common chromosomal disorders. Multifactorial disorders. These are disorders that have a combination of genetic and environmental causes. And we're going to talk about some of the environmental causes of some disorders as well. This is a disorder that results from the interaction of your genetics and the environment. So whenever a person is pregnant, they're supposed to have somewhat of a restricted environment, yeah? There's things that you can do when you're not pregnant that you're not supposed to do when you are pregnant. Does that make sense? And y'all, I'm sure that y'all have heard that before. Multifactorial disorders, it's something that is a combination of your genes and your environment. So you don't want to put yourself or put your fetus in a certain environment if you can avoid it. I don't know, was I talking to this class about, did y'all see that, like the nuclear, was it a nuclear or was it a like chemical plant or a plant exploded in China? Do y'all remember? Did y'all see that on the news? Nobody saw that on the news. Nobody watches the news regularly. That's not good. So there was like a chemical plant or a radiation plant. I mean, it exploded, and like a lot of people died, and also a lot of people were exposed to chemical radiation that they would not normally be exposed to. And of course, like if you've ever had an X-ray or something, like they put like that vest on you, that anytime you're exposed to that in a medical profession, in a medical field, you're like covered in some way to not get exposed to too much radiation. So
That'll work.
no, it's not right. Here, I'll show you. So it's offset. And Randy said there was a remote I could press, but I don't see a remote anywhere. So I don't know where that remote should be. Yeah, I don't know if they put them here would that solve our problem?
We'll try. It should, though.
Okay. Thank you.
No problem.
Okay. So just remember, multifactorial means multiple factors involved in developing the disorder, and those factors include both your genes and your environment. And in order to study more multifactorial disorders, because most disorders are multifactorial, it's very rare that we have disorders that are purely genes or purely environment. Most of the time, there's a combination of the two. Behavior genetics seeks to understand how genetic and environmental factors interact to produce behaviors, characteristics, traits, and even some disorders. So remember when we talked about nature versus nurture, or nature and nurture, understanding the interactive dance between our genes and our environment. And the research designs that are often used are adoption studies and twin studies. So does anybody know what an adoption study is? Okay. It's a way for behavior genetics. We're looking at your genes and your environment. So what's a way that we can separate somebody's genes and their environment?
Put them in a whole new environment.
Taken away from the mother because the mother is just like a unfit parent, and then they go into
Or so essentially, if somebody is adopted for whatever reason, you could be adopted because your parents can't take care of you, or because something unfortunately happened to your parents, whatever. Okay, if you're adopted, you have the same environment as your adoptive parents, right? But do you have the same genes as your adopted parents? Right, so you don't share any genetic characteristics, but you share an environment, okay? So that's one way of separating genes and environment to determine for certain traits. We may say, is that more of a genetic trait, or is that more of an environmental trait? Or something that develops in your environment. Does that make sense? Okay, and also twin studies are a similar thing. There are a lot of twins that in the early, when they were doing all those adoptions and stuff in the early, 70s and 80s, it was common for twins to be separated at birth if they were going to be adopted. Right, nowadays I don't think that they would do that so much, but back in the early, 70s, 80s, they kind of didn't really think about it. If somebody said they wanted one kid, another person wanted one kid, they split up the twins. So in twin studies, we can look at twins who are separated at birth who have the same genes or very similar genes, but they're raised in two different environments. Does that make sense? And then we can study their behaviors, their characteristics, and their traits, and we can determine whether or not those are more environmentally influenced or more genetically influenced. Confusing? Does that make sense? So make sure you know what an adoption study is, and make sure you know what a twin study is. Both are carried out with the goal of separating a person's or studying the separation of a person's genes and their environment. Now, we couldn't go up to a set of twins and say we're going to separate, your kids at birth because that's what we want to do. But there are a lot of people that has already happened to, so they're just being studied to determine how those two things are separated out. Does that make sense? So with behavior genetics, there are 3 correlations that you're going to have to know and that you're going to have to understand. And these come from twin studies and adoption studies and studies of separating out a person's genes and their environment. And these are ways of trying to understand what causes a certain behavior. And they've come up with 3 ways that they think behaviors, characteristics, and traits are developed or can be developed. The first one is an evocative genotype-environment correlation. This is an environment where the child solicits or evokes certain responses from the environment. So an evocative genotype-environment correlation, the child is soliciting something or evoking something from the environment. Okay? And I'm going to give you an example. Okay? Imagine that you have a child, and your child is constantly, they're young, even before they can talk, they're constantly singing. Or they're making vocalizations that sound pretty rhythmic, pretty melodious, pretty good, and you're like, oh, like you sound better than the other kids. What might you do as a parent? You might put them in singing lessons. Okay? You might put them in the church choir. You might do something like that based on what? What's causing you to do that? Are you just saying, oh, I always wanted my kid to be in ballet, so I'm putting her in ballet? Is that the reason why you're doing it? Why are you doing it if you're the parent?
Because
To help enhance. To help.
Because why?
It's because it's already.
Because you've seen something that's already there, and you're responding and changing their environment based on what's already there. Does that make sense? Okay? So if you have a kid that is really young and you notice that your kid runs faster than all the other kids, what might you do? Okay? You might. So essentially what you're doing is the child is doing a behavior. The child is expressing some sort of genetic trait or expressing some sort of behavior, and you are the environment. So the child is evoking a response from you based on their genes. Does that make sense? Kind of. Maybe.
And you said they're the environment for parents?
Yes. Mm-hmm. Or have you ever seen, whenever kids are born, like some kids are happier and they're more smiley, and some kids are more like serious and not, right? So with the kid that's more happy and more smiley, what do people tend to do with that kid?
Put them in
Bless you. Huh?
Put them in ag.
Well, people take lots of pictures of their kids no matter what. I think people are just taking pictures of their kids. But if there's a kid that's more friendly and happy and smiley and outgoing, what might happen? What might people do with that kid?
They might try to put them in commercials and sell those and the next
Market
baby.
People are going to be more likely to be attracted to that child. People are going to be more likely to go and pick up that baby or play with that baby. Like my friend has a set of twins. One of them, happy, cool, no matter what, she's not going to cry. The other one, always got a mean mug on her face. So whenever I go over, which one do you think I'm picking up? I'm like going for the girl that's like, I'm like, I know she's not going to be pissed off at me no matter what I do, right? So that's an evocative genotype environment correlation. Her genetics, she's just more happy, she's more bubbly, she's more go with the flow. So more people are going to respond to her than they will to her sister, her twin sister. Does that make sense? Sort of, kind of? Okay. Passive genotype environment correlation. Influence of the environment is going to activate certain genes. Okay? So you have a genetic propensity for something, but it will not be activated unless a certain environment is achieved. Okay? So a passive genotype environment correlation. So you have the genes for it, but you will not express those genes unless a certain environment is achieved. Okay? So this one, it's helpful to think about this one in terms of a disorder, right? So if you have genes for, I think I said this before, if you have genes for skin cancer, you should probably stay away from what environment? Or a tanning bed, right? So oftentimes we don't know what genes we have and what our genetics is all about. But the environment is going to activate certain genes. So if you spend a lot of time in a tanning bed or a lot of time in the sun or in a convertible all the time, then you're more likely to activate those genes because of the environment that you're in. Does that make sense? Okay. So like if your kid has a certain genetic propensity for whatever, I think I was talking about this one too, for PKU. If your child has PKU, they have to have a certain diet. They cannot go off of the diet that they have, or else it will cause them a lot of problems, right? So if you have specific genes, then your environment can activate those genes. If you eat a certain type of food, you're going to get really sick. Or what is it? People that have like that gluten, whatever. Or my mom has this new thing. Well, it's this new thing for me. My mom has like glucose intolerance or something like that. So like it could become diabetes. Like if she doesn't control it with her diet, she'll become diabetic. But if she has a diet that has pretty much no sugar, no carbs, no grains, she can't have any of that stuff, then she can manage her blood sugar that way. Y'all probably know more about that than me. Or y'all will if y'all are going to become nurses. So the goal is the environment is activating your genes. You have genetics. My mom has genetics to become diabetic, but she can control it with her environment. Oh, and the last one is the active genotype. This is an environment that a child seeks due to genetic preferences. And this is also called niche picking. How many people went to high school? How many? Hopefully. Okay. And when you're in high school or when you're in a certain environment, you can seek out certain clubs or certain sports teams or certain things that you prefer in your environment. Or that you prefer based on your genes. Okay? So, if somebody's joining the speech club, what would we expect? What kind of genetics might they have?
They'd be talkative.
They might be more talkative. They might be more outgoing. They're going to seek that. You're not going to join the speech club if you're shy and inhibited. If you're shy and inhibited, what might you seek out? I don't know. Maybe nothing, right?
Being at home by yourself.
Or maybe,
Always want art, like shy.
Or maybe an art. Yeah, you might do like a art thing where you can draw and you don't have to say anything, right? You're just sitting there by yourself, drawing, and you show your artwork. Okay? So make sure you know for the active, make sure you know the difference between active and evocative. Active, the child is actually seeking it out themselves. The parents have nothing to do with it. The environment has nothing to do with it. In active, the child, is going and finding those things that they want to do. In evocative, somebody in the environment sees something in the child and tries to enhance that based on the child's genetics. So make sure you know the difference between those two. Okay, and let's talk a little bit, and I'm going to go through these quickly, about the critical factors in prenatal development. Again, the age of the mother, 18 to 35, good childbearing years. Over 35, more likely for infertility issues, genetic disease. Under 18, more complications with delivery. It's important to have adequate nutrition. If you don't have adequate nutrition, that can cause bad things. Spina bifida is when a birth defect that can be caused by lack of adequate nutrition. It's normal to gain 25 to 35 pounds. And when we talk about environmental issues in prenatal development, it's important to talk about teratology. This is the causes, mechanisms, and patterns of abnormal prenatal development. Teratogens are anything that can cause abnormal development. Teratogens are always things in your environment. So things in your environment that can cause abnormal development in a fetus. For example, if you drink while you're pregnant. Alcohol would be considered a teratogen because that is something that will cause abnormal development in a fetus during prenatal development. The teratogens are determined by, of course, the genetics of the child, how severe and how often the teratogen is exposed to the child, what the teratogen is. The impact may be immediate or delayed, and it also depends on when the teratogen was influenced. Was it influenced early on in the first trimester, second, third? In the germinal period, that's early on. Embryonic period, towards the middle, and the fetal period is towards the end. Okay, some teratogens, for example, are alcohol. Fetal alcohol syndrome can include physical abnormalities, cognitive deficits due to drinking during pregnancy, malformations of the face, could cause mental retardation, could cause low IQ. High caffeine consumption is not good during pregnancy either, may lead to low birth weight, miscarriage. Nicotine, cigarettes, those are not, those are also considered a teratogen. Decreases oxygen in the blood, can cause premature delivery, lower IQ, heart defects, and infant death. And also prescription medication. So some prescription medications, if you're taking antidepressants or if you're taking some form of prescription medication, that could also act as a teratogen to your developing child. I think they're always trying to find like a good prescription medicine for what is it? Whenever like early
ADHD?
on. No, when you're early on in your pregnancy and you have
Nausea.
you have nausea, you have like what's that called?
Morning
Calls
sickness.
that morning sickness. They're always trying to find
They have like the
something
the
that's not going to
Finnegan
be a
and the-
teratogen
yeah.
to the baby, but that will cause the mother to not feel so bad with morning sickness. But a lot of them are up in the air. Some people say, oh, this is fine, but then the FDA didn't approve that. So it's really like a thing. Let's pick up here when we come back on Wednesday. Don't forget to turn in your homework assignment by 11:59 p.m. tonight.